I've been trying to put some of the documentation for these controls on the site at AutoControls.WordPress.com, which I'm hoping will be around for a while, even if I'm not around. And that's part of the AutoControls.org site right now. If you go to AutoControls.WordPress.com and you scroll down, you can probably the easiest thing to do is just use your browser search tool and search for 827, but this is video 827, and there's a link here for Google Drive album 827. If you click that link, it'll open a Google Drive album, and here is the wiring diagram for this this video, and in here is the command file, a copy of the PDF command file, and also put the original documents, which will be an open office document for this thing, which you can open either with the free open office application or open with Microsoft Word. This wiring diagram was drawn in a Macintosh application called Intaglio, so you really can't open this without having a copy of Intaglio, but it is there if someone has that tool available, if they want to use this or modify it. Here's the wiring diagram for the control panel. We've got the mini panel here in the center, the command station up here, and in this it shows a Powerhouse Pro. In the video I'm using a power cab, but in either case you got two wires, power wires coming out of it that go down to the track. In this orange line here, we're calling this the control panel layout interface. In other words, what's above this orange line is on the control panel, and what's below the orange line is on the layout. And here's our Z-stuff detector, and these are buttons. These are the buttons in the front that you can have for the public to operate a display. In this video, we're using what's called button 2 that operates 3 trains. It's connected to input 2, and if somebody pushes this button, if someone from the public pushes this button, it'll start the trains up, and we can hide that just to make the drawing a little bit clearer. Let's see if we can hide the now the public buttons went away, and that cleans things up a little bit. And we've got those same 2 buttons on the control panel itself. Here's the one for 3 trains, and here's the one for 2 trains. And we've got the 3 switches we were using. Our continuous run switch hooked to input 18. Our switch hooked to input 20. It increases the delay. And then our switch hooked to input 24 that keeps the train in the yard moving continuously. And then over here is our reset button that we can use if we have to reset the mini panel. Down here is our Z-stuff detector inside this yellow box, and this is showing the wiring for a DZ1011, and what we were actually using in the video as a DZ1012. But this could be, and as a unit, taken as a unit, which is the way I've got it, it's already wired up. We have 2 inputs for power coming in off the track from over here, and then we have 2 outputs going to the mini panel. The black is the ground, and the yellow one is connected to terminal 14 on the mini panel. But this is the relay is normally open. You can see the contact is touching the gray wire, which is the normally open wire, normally closed wire, which isn't connected to anything. And when an engine goes in front of this and changes it from green to red, the block signal detector causes the relay to go to its closed position, which means this contact point will swing down and touch this gray line, which will connect the black to the yellow wire. And essentially, at that point, the mini panel's terminal 14 is connected to ground. The relay is doing that, and that signals the mini panel that terminal 14 or input 14 is activated, and then it executes that command. That's the wait statement that looks at that command. And as I mentioned, this could be this is an infrared detector, but it could be a reed switch or an electric eye, or really anything that causes these two wires to be connected together. It could be you standing there with a pair of wires and just touching them together, which is essentially what a reed switch almost does. Or you could have a push button mounted there and have your 8-year-old grandson standing there pushing the push button when the train went in front of it. Just like I say, the detector can be anything that connects these two wires together that tells the mini panel that the train is there. And the only thing you got to be careful of, and I made a note up here, you have to be careful you don't connect any power to the inputs of the mini panel, because this thing has its own little, I think it's 5-volt power supply that it uses to operate the inputs, and that's typical of most of these electronic black boxes, that they've got their own little power supply that they can detect when the input is grounded, and it will damage them if you connect an outside source of voltage. So you got to be careful about that. Input 16, you can see there's a wire, but that's not used in this video. Some of the other videos, I've actually got two detectors, and that's why there's a wire here. But this video, we're just using single input 14 for sensing where the trains are. And then I mentioned the switches already here. In these brackets that you see me mounting the switches on, you can actually get these from Lowe's or Home Depot, just the little 1-inch angle brackets. And taking another look at the logic of how this works, these two trains are sitting in the yard, stationary, and this engine's coming in off the main line, moving. And as this engine moves and crosses a detector, that causes the relay to close, and the mini panel knows this engine is there, and it starts up these engines. And the first thing it does, it starts this engine in the yard up at speed 5. Actually, let me back up. It slows this engine from mainline speed 8 down to speed 4 as it's coming in the yard. It immediately starts this engine up at speed 5, and it sends this engine out on the main line at speed 8. So it's basically out of the picture, traveling on the main line. This engine moves up to the front of the yard. This engine that was coming in will move into the rear of the yard. So and then it stops those two engines. Meanwhile, this engine that's set out on the main line is traveling around the main line, and when it makes a complete loop and comes back in again, the cycle starts all over again. This will cross in front of the detector, slow this engine down to speed 4. It'll start this engine up at speed 5, and it'll send the front engine in the yard out on the main line at speed 8. So as this one's going around the main line, these two will move up in the yard and park themselves, and then the same thing happens all over again when this engine goes around the loop and comes back in, crosses the detector. It'll slow it from speed 8 down to speed 4, start this engine up at speed 8 on the main line, and it'll start this engine in the yard up at speed 5, so it moves up to the front of the yard. This engine's moving at speed 4. It comes up in the rear of the yard and parks, and then waits till this engine goes around the main line and comes in again, and that's back to where we started. And the cycle will keep repeating if this switch is closed for continuous run. If this switch is open as it's shown here, the mini panel will detect that, and it'll send a stop command to this engine and they'll park, as you saw in the video, and they'll sit there in their parked positions waiting until somebody pushes the push button again, and then the cycle starts all over again. Let's take a closer look at the commands this mini panel uses. You can see the power cab is still laying up here. I've got a Pro cab I use for programming, and I'm going to plug it into the programming port. That's what the single port is here. These are the two normal bus ports where you plug your cabs in, but they give you a single port for programming. When I plug that in, you might have noticed that screen lit up because this is now getting power from the mini panel. And now it gives us an option to set up, review, or test operation. We're going to select number 2. I'm going to push the number 2 button, which will give us review. And then it says review what input. I'm going to tell it input 1 and hit the enter. And let's see, our command for our button that started these 3 trains, I believe, was on input 2. So we'll go to input 2, and there's select Loco 957. That's that Union Pacific, what we're calling the yellow train, the Union Pacific E9 pulling the passenger cars. So it selects that Loco. The next thing it does is turn on the lights. That's what F0 controls the headlight. And then it sends a speed forward 8. That starts it up at mainline speed. And then the next command is link to input 14. That jumps it up to input 14, which is where our 3 train program is located. We normally use inputs 1, 2, and 3, or whatever number, several of the lower ones for hooking up buttons. And then after that, you set your, what they call setting your memory continuous and telling it to not look at the inputs for your real operation. I'll say more about that later, but let's go up to input 14. I'm just stepping through the inputs here. Now here's where the real program for our 3 train operation is, and it says wait till input 14 is ground. That's the Z stuff detector we just looked at. That's at input 14. So whenever the mini panel will sit there at this statement and do nothing until the train crosses in front of the detector. When it crosses in front of the detector, input 14 will be grounded, and then this thing will stop waiting and go on to the next step. So the next step is speed forward 4. That decreases the speed of that Union Pacific passenger train, the yellow train, to 4 as it's coming into the yard. Then the next thing we do, we select Loco 74. That's the one the Alco, the red passenger train that's sitting over at the rear station. We select that Loco and say speed forward 5. That starts it moving at its yard speed. Then we select Loco 9088. That's the freight engine that's sitting up at the front station, and we send that out on the main line at speed 8. So we've taken care of getting the front engine moving onto the main line, and our 2 engines in the yard are creeping. And then we come back to Loco 957. That's the rear one that just came in the yard, the yellow train, and we blow the horn. This is the 2 turning on function 2 blows a horn. We delay for 3 seconds, a quarter times 12, and then we turn the horn off. That when we send this command, it keeps the headlight on, function 0, but you can see function 2 has been turned off, so that stops the horn from blowing. Then we delay for 15 seconds, which is our basic delay built in to bring the engines up in the yard. And then this is our additional delay, which I'm going to skip over here. And then we set the speed to 0. That stops that yellow engine. And we'll also select Loco 74, which is the Alco, and there's a couple commands here, but that sends a speed forward 0 command, and that'll stop that also. So what I wanted to demonstrate, and this is basically it for the first cycle, then it repeats all again for the next sequence when the next engine comes in, which will be the freight engine, and then it repeats a 3rd time for the third train, which is the red passenger train, but it's basically the same commands with just different input numbers. But what I wanted to emphasize is these are basically commands that are all easy to understand. They're basically speed forward 0 is stop the train. That's pretty obvious. Speed forward 8 is start it. So compare this to like an Arduino, the code that's in an Arduino or the code that's in a pickaxe, and it's much easier to understand. So people get scared about this programming, but when people get scared when they hear the word programming, but this stuff's really pretty elementary. For getting started using this mini panel, there's an earlier video, 816. It's a 5-part video titled Beginner Exercises for NCE Mini-Panel Automatic Train Control. And I try to take you through the basics to the best of my ability of setting up the mini panel, understanding it, and doing some real simple exercises for automatic train control, starting with just blinking the LED light, running one train and then working up to running 2 trains. This shows demo 14 running 2 trains, but you can see here I'm actually taking you through the programming to set this thing up, and you use basically a cheat sheet. You can see maybe where my finger is. I've got some numbers written down, and that's a cheat sheet that just tells me what I need to type in. You can see all I'm doing is poking the number keys to type in the commands up here for this thing, but that's how you program this. And if you want to do this, I recommend you start with this video and do some of the simple exercises. Here's what I call the program file. This is a word processing document. I use OpenOffice, which is a free program that runs on both Mac and Windows. You could also use Microsoft Word. You could use a tablet. You could write this on a napkin or write this on toilet paper. If you got a photographic memory, you could keep it all in your head, but I need it written down. Anyways, I keep track of my Loco settings, what my Loco numbers are, what speeds I run them at, what momentum I have them set at. These Katos, I've got them set at 50. The configuration of the mini panel, normally you don't change these very often. These 2 I've got here in the circle, continuous memory, I start at 4 and above, and I've disabled inputs 4 and above. In other words, the first 3 inputs are set up for push buttons. It'll be the mini panel will be monitoring those 3 inputs continuously when it's idle to see if a button gets pushed. 4 and above disabled inputs, it won't be looking at those unless it's specifically directed to do so via a command. In other words, if I have a command that says wait until input 14 goes to ground, then it looks at input 14, but otherwise it won't. And down here is what I referred to earlier as my cheat sheet, command library examples, and these are all the commands I use, and what's in the red is the things that change, and the other part in black always stays the same. Like if I want to start a Loco up at speed forward 10, the commands are 322 10. F for forward, or if it's speed 9, I would put a 9 there instead of 10 where you see the red. But this is the easiest way I've found to program this. What you're actually doing with these numbers is stepping through like a command tree, but it's time consuming to do that, so for me it's just easier to have this cheat sheet. This is page 2 where we handle the push buttons. Here's inputs 1, 2, and 3. Our push button 2 that we use to run 3 trains in this video has these commands in it. It selects the first Loco 957, turns the headlight on, starts it up at speed 8, and then it links to input 14. This basically goes up to input 14 in the memory and executes the program that runs the 3 trains. And in the input 3, that just links down to input 4, which is here, and this is a little routine that tests the detector. If you recall in the video, we pushed a piece of rolling stock in front of the detector to just demonstrate how it changes from red to green. And when that happened, the light started blinking on the mini panel. And this is the routine that causes that to happen. Basically, how this works, it says skip if input 14 is open. And if input 14 is open, it'll skip to the next. It'll skip over the statement to the next statement, and then there's more skip statements. So if none of the inputs are closed, it'll just skip down to the bottom, delay for a half a second, and then it'll go back to input 4, which is back to the top. So it'll just keep running this little routine without doing anything if none of the inputs are closed. However, when we push something in front of the detector that causes that relay to close, then input 14 will be grounded, so it'll come to this statement, skip if input 14 is open, but input 14 is closed, so it'll execute this command. And this is just a dummy command telling the mini panel to send a command to set turnout number 2000 straight, norm is straight, and that's what this command is, and the LED will blink. And then it'll keep doing that approximately once every half second, because it'll keep looping as long as that's closed. And likewise, if we push one of those two buttons, button 1 or button 2, if we push those, it'll cause the mini panel to blink also. Now there's no exit from this routine, so here's where we use the reset button to stop the thing from executing this program. As we continue through this word processing file, page 3 contains a routine for running 2 trains, which we're not using in this video. And if we go to page 4 contains a couple photos of the layout. Going to page 5, this is the first part of the routine for 3 trains. I put it on 3 pages just to keep it easier to view. This is the first loco in the sequence where we start out, and then page 6 is almost the same, the second loco in the sequence, basically the same commands, just different numbers. And then page 7 is the third loco in the sequence, and again the same sequence, same commands, just different numbers. And then at the bottom in the green here, there's a routine that tests whether to keep running or whether to quit. Now we'll take a closer look at the commands used for the 3-train operation. This is the first 1/3 of those commands for the first engine. What we've got is these 2 engines sitting stationary, parked in the yard. This engine's on the main line moving, and it's coming up to the detector. And when it crosses the detector, then we'll send commands to start these engines in the yard moving. Now, there's some optional commands here in the blue boxes that are controlled by those switches. Actually, well, this is the horn blowing commands. You don't really have to have that. This is the additional delay commands in this box. You don't have to have that. And then down here is the commands to keep the middle engine in the yard moving instead of stopping it. So we can make this look a little simpler if we cover those up and just look at the basic commands, which is what we have here. So we've got this engine moving toward the detector, and we've got this wait until input 14 is ground. So that's the detector's hooked to input 14, the relay, I should say, of the detector. So when that detector, be it the Z stuff or a reed switch or whatever, when those wires are closed at grounds input 14, then this command will be executed, and it'll go on to the next command, and it'll say speed forward 4. Now recall back when we looked at input 2, where the push button was connected to, that command, before it linked to input 14, that command selected this loco, turned its headlights on, started it moving at speed 8. So that engine's moving. now, but when it crosses in front of the detector, we'll send the speed forward 4 command, which will slow it down to a yard speed of 4. Next, we'll select Loco 74, which is this one. We'll start it up at speed 5 to get it moving. Next, we'll select this Loco 9088, start it up at mainline speed 8, so it'll pull out of the yard and go out on the main line. So at this point, we've got what it looks like down here. These two are in the yard. This one's out on the main line. So we come back and select Loco 957, which is this one. We put a delay 15 seconds. Then we send a stop command, which stops that Loco. The next thing we do is select 74, which is this Loco, send it a stop command. So that one stops. So at this point in the program, we've got these two engines stopped in the yard, and this one's out on the main line cruising at mainline speed 8. Let me mention this note up here I have in green. I made these pictures for the video, just try to make it to try to make it clear where the Locos were, but you may not want to do that if you're experimenting yourself. But here would be an easy way to handle the notation. I made this is the detector. I put it in brackets, and then these are the two Locos that are parked downstream of the detector, number 74 here in the red, and 9088, the freight engine, and then 957 is the E9 that's moving on the main line. So this notation here tells me where the Locos are, which two are parked, and which one's on the main line. Now, talking about this delay statement some more, here's our delay statement, 15 seconds. And remember, this delay statement controls how long these two engines move in the yard after this one has crossed the detector. This one's been sent out on the main line, but we're executing a 15-second delay statement to pull these up into the yard. And the minimum delay has to be long enough that these get far enough ahead of the detector so that then when this one comes in off the main line over here, that these two can get started and get out of the way of the train coming in off the main line and not get bumped in the rear end. And the delay can be longer, which will cause them to move forward for a longer time, but it can't be too long because this delay statement has to finish before the train comes in off the main line, so that the next wait statement, this is actually the one from the next page, so that the next wait statement will not be missed. If the delay is too long, you can miss this wait statement, then things are out of order. Now let's take a look at these commands that are covered up. Recall this one blows the horn. This creates more delay. And these two keep the front locomotive running. So if we uncover those commands, here's our horn command, and these are all optional. But this one, function 0 turns keeps the headlight on, and function 2 turns the horn on. So this one begins blowing the horn. Then this one delays for 3 seconds while the horn blows. And then this one turns the horn off, but function 0 keeps the headlight on. So these commands blow the horn. Now this is our optional delay. It says skip if input 20 is open. When I closed switch 20 by pulling it up, then when the routine comes along, switch 20 is closed. It won't skip this command. It'll execute it instead, and it adds an additional 10 seconds of delay before the train stopped, a quarter second times 40, and that'll add extra delay. Now down here is the commands that cause the middle Loco, which is this one here, to keep running. Normally switch 24 is open, so it'll come down through here. It'll say skip if input 24 is ground. If it's open, it'll stop this engine, which is a normal routine. Then it skips over this command since switch 24 is open. However, if we close switch 24, which we want to do to keep this loco running. Then when it comes down here, it'll skip the over this statement because it is closed, grounded. It'll skip over the stop statement. This one, it won't skip. It'll send a speed forward 6 command, which will have this one continue running at speed 6 on the main line. So that causes this front loco in the yard, instead of stopping, to keep running continuously. So you can see we've got a speed forward 0 and a speed forward 6 command, and depending on the position of the switch 24, it'll either stop the loco or keep it running. Now here's page 6, which is the second part of the sequence, and it's basically the same thing all over again, except our locos are in different positions. So it's the same commands, just different loco numbers. And again, in this blue box shows the notation that we use to keep track of which locos where. It gets the most confusing part is trying to send the right commands to the right loco, and this notation helps you work that out. And again, we've got our optional commands covered up. If we show those commands, it looks like this: honk the horn, the additional delay, and either stop or keep running for the front loco in the yard. Now here's page 7, and this is the third and final part of our sequence. And again, the same notation at the top in the green box, and our same commands we sent as before, and the horn and the more delay and the keep the front loco running. Those commands are basically the same. It's just different engine numbers. Now, the one thing we have on the last page, we have the test of whether to repeat the sequence or quit it. And let me see if I can scroll the screen up a little bit here, and we'll discuss that. We have so here's our keep the front loco running command, and then we select loco 957, which is the one that's out on the main line, and we have a test whether to repeat or quit. If switch 18 is closed, we're going to repeat. If switch 18 is open, then we'll stop everything. So when we get down to this line, we've selected loco 957, and we need that selected in case we repeat. And this command could be at the beginning of the routine. I just have it at the end. It could be up at input 14, but it's down here right now. So we test, and if switch 18 is closed, that means we want to repeat. So it'll not skip. If switch 18 is closed, the skip won't happen, and we'll execute this statement linked to import 14, which goes back to the import 14 and repeats the sequence. However, if this switch is open, we'll skip over the link statement into what I call the shutdown routine. And since we've got loco 957 selected, when we send this speed forward 0 command, that'll stop this loco. And this engine may be moving depending on what happened here. So we've got to make sure we stop that loco. So we'll select 988, which is the front loco in the yard, send it a speed forward 0 command, which will stop it. So at this point, all 3 locos are stopped, and we send a terminate command, which just ends the mini panel's processing. And then the system will sit there and wait for 5 minutes, an hour, however long. If somebody comes along and pushes the push button, things will start up again.